This video is not intended to replace the Komatsu Operation and Maintenance Manual, Machine Shop Manual, or Engine Shop Manual. It is the operator's and distributor's responsibility to read these manuals before operating or maintaining this machine. Improper use of this machine may cause serious injury or death. Welcome to Komatsu America Corporation's technical troubleshooting video on Tier 4 Interim midsize engines. The purpose of this video is to familiarize the service technician and service management staff with the proper approach to troubleshooting Komatsu's construction equipment that includes engines with Tier 4i KDPF after-treatment systems. By adopting this troubleshooting strategy, your distributorship will create efficiencies among its branches and unify the test methods and data collected across the network of North American distributors. This will allow KAC's technical support staff to expedite technical service request, or TSR resolutions, as well as collect data that could indicate trends with certain components. In addition, proper troubleshooting techniques will reduce replacement of expensive components that are only indicating trouble and not the root cause of a problem. Our video will start today with a brief overview of how the Komatsu regeneration after-treatment system works. Then we will review the major components of the Komatsu Tier 4i engines from the 6D107 6.7 liter to the 6D140 15.3 liter sizes. Next, we will focus on the tools and test methods for performing troubleshooting. These tests have been placed in this order because of our experiences with our engines. It is very important to point out that the foundation of our video is Flash News FN 12061, issued 12/11/2012. This Flash News provides supplementary regeneration troubleshooting checks in addition to those contained in the shop manuals. Regeneration trouble often has multiple causes. Each of the checks should be completed to ensure a full repair is performed. The Komatsu diesel particulate filter, or KDPF, is usually a victim part that has failed as a result of other issues. Regeneration will not return to normal until all issues have been addressed. Good troubleshooting efforts come from thorough troubleshooting methods. The Komatsu exhaust after-treatment system is designed to collect and eliminate exhaust particulate matter, or PM, through a process called regeneration. The regeneration process uses a chemical reaction called oxidation to convert solid material, soot, into gaseous material that is not harmful to the environment. Komatsu Tier 4 Interim machines can accomplish regeneration by a number of methods. The first type of regeneration is called passive. Passive regeneration is the simplest type of regeneration and only requires a functioning KDPF and exhaust gas temperatures above 250 degrees Celsius, 480 degrees Fahrenheit. Passive is invisible to the operator and occurs continuously as a machine is worked. The concept of passive regeneration is simple. A machine being worked hard can eliminate particulate matter at the same rate the engine is producing it. This results in a net soot load in the KDPF of 0. During engine idling, passive regeneration does not take place. The next type of Komatsu regeneration is called active. Active regeneration is a process where small amounts of diesel fuel are injected into the exhaust stream before the KDPF. The purpose of the fuel addition is to create additional heat to speed up the oxidation process. Active regeneration does not begin until 3 soot bars are showing on the 0 to 8 soot bar scale. Machines that are only lightly worked or idled too much cannot eliminate soot fast enough with passive regeneration, and the particulate matter builds up. That is when active regeneration is automatically triggered. In Komatsu machinery, the operator will know active has begun when an icon lights on the monitor and a slight increase in turbocharger speed is detected. Active regeneration does not interfere with normal operation on Komatsu Tier IV machines. The operator should continue to work the machine. In fact, the harder the machine is worked, the quicker the active regeneration process will be completed. An active regeneration is completed when the soot bars in the soot bar graph have been driven down to 0 bars showing. There are applications where an operator will want to disable an active regeneration as it begins. These include machine operations that take place around combustible materials. When a machine is working in these conditions, move the machine to a safe location and perform a manual stationary regeneration. As the name implies, a manual stationary regeneration is performed with a machine parked, safety lock levers locked, and/or transmission in neutral, fuel dial accelerator pedal at 0, and parking brake applied. Manual stationary regeneration cannot be started until 4 soot bars are indicated on the soot bar gauge. After the operator has parked the machine correctly, manual stationary regeneration is enabled in the User menu, KDPF tab. Once started, the operator will hear a slight increase in engine RPM and turbocharger speed. If any of the lock levers, fuel dials, accelerator pedals, gear shift levers, or parking brake are moved, the machine will automatically stop the manual stationary regeneration. For the service technician, there is one more type of regeneration process. This is called Manual Stationary Regeneration for Service, MSRS. This is accessible through the service menu in the monitor and can be started by the service technician no matter how many soot bars are indicated from 0 to 7. When 8 soot bars are indicated, all types of regeneration are disabled except for passive. The MSRS can be started and stopped by the technician and should be used for troubleshooting, as well as before and after changing KDPF assemblies on machines. If an MSRS is started but not stopped by the technician, it will terminate itself after 40 continuous minutes. As the name implies, an MSRS is performed with the machine parked in a safe environment, and all the same lever, pedal positions, and safety devices are applied that are required for a manual stationary regeneration. The Komatsu Tier IV Interim after-treatment system consists of many integrated components, each of which contributes to low emissions and lower fuel consumption. Now we will focus on some of those components and explain the changes from Tier 3 to now. Komatsu has built upon its experience with high-pressure common rail technology by raising the HPCR pressures for Tier 4 Interim. The concept here is simple. Higher injection pressure means better atomization of the fuel, which results in less particulate matter, PM, creation. For you, the technician, this means less soot. To create higher common rail pressures, Tier 4i machines require clean, ultra-low sulfur diesel fuel. This is a standard requirement created by the United States EPA and should not be overlooked by the technician visiting a troubled machine. Komatsu has also embraced the use of variable geometry turbochargers for their Tier 4 Interim products. This technology creates higher boost air pressures at idle RPM, effectively eliminating turbo lag when engine RPM ramp up during operation. The service technician should realize the elimination of turbo lag results in the reduction of excess particulate matter. The Komatsu version of these new turbochargers are called Komatsu Variable Geometry Turbocharger, or KVGT. And what sets them apart from other VGT is that Komatsu uses hydraulic actuators for the turbo geometry changes. Another component added to Tier 4i that was not used on Tier 3 engines is the mass airflow, or MAF, sensor. This sensor is mounted in the outlet tubing of the air intake filter assembly and measures the mass of air entering the engine. It is important to remember air mass is the weight of the air over a period of time, usually displayed as pounds per minute or kilograms per minute. Fresh intake air is mixed with recycled gas, called EGR gas, and the service technician should be familiar with the exhaust gas recirculation, or EGR system. This system was present on the larger Komatsu Tier III engines, but was not present on the 6D107 or the 6D114 Tier III engines. EGR is now used on all the Tier IV machines. The principal purpose of using EGR is to reduce combustion temperatures inside the cylinder. This results in a reduction in the amount of oxides of nitrogen, NOx, created during engine operation. Lower NOx is one of the major requirements of the Tier IV engine emission regulation. The two major parts of the EGR system are the EGR valve and the EGR cooler. On Komatsu Tier IV mid-size machines using the 6D107 through the 6D140 engines, the EGR valves are hydraulically actuated. The heart of aftertreatment systems for Tier IV Interm engines is the diesel particulate filter. As the name implies, particulate matter is filtered out of the exhaust stream as it leaves the machine. The Komatsu diesel particulate filter, or KDPF, has many features that give Komatsu a major advantage in the marketplace with its advanced aftertreatment system. The Komatsu KDPF consists of the KDPF inlet section, including a diffuser and the inlet temperature sensor. The next section is the Komatsu Diesel Oxidation Catalyst, or KDOC, which consists of a ceramic substrate coated with oxidation catalyst. There is a space between the KDOC and the next section, which is the Komatsu Catalyzed Soot Filter, KCSF. Mounted in the space are the KDOC outlet temperature sensor and the inlet to the differential pressure sensor. The KCSF is the filter inside the KDPF assembly. The KCSF is made of porous ceramic with every other cell blocked on the exhaust outlet end. This creates dead-end cells that trap particulate matter such as soot. The section after the KCSF is called the KDPF outlet, and mounted here is the KDPF outlet temperature sensor and the outlet from the differential pressure sensor. Another component the service technician should be able to identify is the Komatsu Closed Crankcase Ventilation, or KCCV filter assembly. Blow-by gas is now counted against the emission standard, so Komatsu is recycling this gas through the KCCV. It contains a filter element which coalesces oil mist and drains the oil back into the pan. There are components that are specific to 6D107 and 6D114 engine families, and the service technician should be familiar with these devices. First is the exhaust manifold pressure sensor, which is mounted on the gear train end of the exhaust manifold. The sensor is remote mounted on the end of a short piece of tubing to keep the sensor away from direct heat. The second unique component is the EGR orifice temperature sensor, which is mounted in the EGR pipe that transitions from the EGR cooler on the exhaust manifold side of the engine to the intake side. There are components that are specific to 6D125 and 6D140 engine families, and the service technician should be familiar with these devices. This engine group adds the fuel used for dosing through an external dosing nozzle. This nozzle is mounted to the side of the exhaust piping after the KVGT and before the KDPF. Fuel is fed to the external dosing nozzle by an electric fuel pump after being routed through the shutoff valve, or SOV, assembly. It is very important for the service technician to perform a preliminary walk-around inspection of the machine when starting the troubleshooting process. Start at one specific point of the machine and look at everything as you move around. Look for any fluid leaks, exhaust leaks, cracks in air piping, damage to hoses, broken or misaligned sheet metal, including doors, fluid levels, water in pre-filter bowl. Open the KCCV and inspect the filter. From the cab, look for fault codes in the service monitor. Run the engine and listen from the ground and walkways where available. Pay particular attention to air leaks and engine sounds. Take good notes, and whenever possible, interview the machine operator. The new Komatsu high-resolution LCD monitor should not be overlooked as an important tool in the troubleshooting effort. Besides giving the machine operator the ability to control various cab features and performance options, it also has many features that can provide the technician with troubleshooting techniques to quickly resolve machine performance issues. The user menu in the machine monitor holds information that may be useful to the service technician when first arriving at the machine. When fault codes are active, icons could be displayed on the live screen. Follow the prompts to view the error list and write down the fault code information. This is the beginning of your troubleshooting data collection. If you haven't already done so, make a written record of the machine model, serial number, calendar date, and service meter reading, or SMR, as well as the active faults, if any. Most of the information useful to the service technician will be found in the service menu of the machine monitor. This menu is locked from the machine operator, and accessing the service menu varies depending on the machine type. Refer to the machine-specific shop manual and go to Section 30, Testing and Adjusting, subsection Electrical, Special Functions of Machine Monitor. Once inside the service menu, there is a list of menu items to choose from. New to the Tier 4i machines are the Monitoring Predefined and Monitoring Custom menus. In the Monitoring Predefined menu, the Komatsu engineers have assembled selected groups of monitor codes and display them on individual screens. Along the bottom are digital graphs showing status of hydraulic oil temperature, engine coolant temperature, and machine fuel level. The number of predefined screens, their content, and what is monitored on the bottom of the screen varies depending on the machine model. In the Monitoring Custom menu, the service technician can choose up to 6 monitor codes from a list of codes, then save them to a screen for future use. This list can later be erased or modified. Fault codes that are triggered during machine operation are stored in the Service menu, Abnormality Record submenu. Just like with Tier 3 machines, abnormalities are sorted into 2 categories: mechanical system codes and electrical system codes. When starting to troubleshoot a machine, it is very important for the technician to write down all the codes listed in the abnormality records. Active codes will have a red E to the left of the fault code listing. Inactive codes may shed light on a previous condition that contributed to your current issue. Mechanical codes cannot be erased from the memory, but inactive electrical codes can be erased. The service technician should make themselves familiar with the default menu and adjustment menu inside the service menu. Changes made in these areas can affect machine performance, and if selected incorrectly, can cause machine faults. The content of the default and adjustment menus vary depending on machine model. Refer to the machine-specific shop manual for a complete listing of menu items. Some of the last menu items listed in the service menu includes the diagnostic test menu and the no injection function. Under the diagnostic test menu, you will find the cylinder cutout test function, along with the regeneration for service function. Because the regeneration for service process is carried out with the machine in a stationary condition, this is often called a manual stationary regeneration for service, or MSRS. The last item under diagnostic tests is the KDPF memory reset function. Do not use this function during the troubleshooting process unless instructed to do so by a KAC engine service engineer. Finally, don't overlook the no injection function provided in the service menu. This enables the service technician to spin the engine for such testing as compression, battery drawdown, and starter speed, as well as lubrication of moving parts on an engine sitting unused for a long period prior to starting. Komatsu has been selling a testing tool called the Handy Smoke Checker for a number of years. Part numbers for these tools include 799-201-9000, 799-201-9001, and 799-201-9002. These tools may have very slight variations depending on when they were built, but the overall functionality for smoke testing is the same. When preparing to perform a smoke test on a machine, the first thing to look up in the shop manual is the required machine posture for the test period. Machine posture includes required fluid temperatures, power mode status, transmission condition, machine work equipment position, engine RPM, and sample timing. For example, the hydraulic excavators require full throttle, P mode, arm in a hydraulic relief. Then take the sample after 5 seconds. The wheel loaders require full throttle, HST stall on HST machine, torque converter stall on TC machines. Take sample after 5 seconds. The bulldozers require full throttle, HST stall on HST machines, torque converter stall on TC machines. Take sample after 5 seconds. The articulated dump trucks are tested 2 ways: high free idle after 5 seconds and TC stall after 5 seconds. Before running the machine, it is a good idea to locate and remove the test port plug. This plug is much easier to remove when the engine is cold. The plug is always located in the exhaust pipe between the outlet of the KVGT and the inlet of the KDPF. However, on some machines, it is behind protective sheet metal panels. Once the machine is up to operating temperatures, go into the user menu in the monitor and disable regeneration. This is to assure that an active regeneration will not begin while the test plug is out of the fitting. Make sure one of the paper test coupons have been installed in the smoke checker. Have the operator put the machine in the correct test posture, and with the machine running as specified, insert the smoke checker nozzle into the fitting. Count to 5. Then pull the smoke checker handle to capture a sample. Remove the paper test coupon and replace it with a new, clean one. Repeat the test. 3 times should be enough for an average. Once the testing is done, allow the machine to cool down and reinstall the test plug. Using the test samples collected and the Bacharach color scale that is included in the Handy Smoke Checker kit, find out which color intensity best matches your sample. This scale runs from 0 to 9, with 9 being the darkest. Your results do not have to be in whole numbers. For example, if your sample is not quite as light as a 2, but not as dark as a 3, then it is possible to call your result a 2.5. It also may be a good idea to write on the back of the paper test coupon and include the machine model, serial number, time, and date. Another tool the service technician should have access to is the Cummins Insight program and associated hardware. Flash New 12061 directs the technician to report fault code CA2777, which reports the operator canceled regeneration events. This is important for your troubleshooting effort, but the fault code is not reported through our machine monitors, nor is it reported through Comtrax. For this reason, you should be familiar with the operation of the Cummins Insight product. The technician will need a laptop computer with the latest version of Cummins Insight and the Inline 5 or Inline 6 data link unit. The data link must be used and updated with the latest firmware. All firmware updates can be found on http://inline.cummins.com. For latest Cummins Insight hardware and software, including Inline 6, please contact your local Cummins dealer. All Komatsu Tier IV Interm units are equipped with a gray Deutsch 12-pin service connection port located in the cab. Most connectors are located in the fuse panel area, typically located behind the operator's seat or on the left-hand side of the seat down close to the floor. Always refer to the machine-specific shop manual for assistance locating the service connector. Note: you can no longer connect to the engine harness, i.e. backbone harness. The technician will need a separate adapter in order to make the connection between the Deutsch 12-pin connector and the Cummins 9-pin connector. This adapter is available through Komatsu Parts, and the part number is 799-601-4510. Step 1. Locate the Cummins Insight icon on your desktop. Double-click the icon and this will start the Cummins Insight program. In the first screen, you will need to make sure you have the correct data link type selected in the drop-down box located in the lower center of the screen. Make sure you are not on simulator mode. If this is the first time you have used Cummins Insight on this laptop, you may need to set up the correct data link. If so, you need to select Add New and follow the detailed instructions to set up your data link. If the data link is set up already, move to Step 2. Step 2. Next, double-click to connect to ECM. You will see a separate window pop up. Click Connect. Step 3. Now you will be directed to create a new work order or select an existing one. For these instructions, we will assume you need a new work order. Click on New. Note, it is always a good idea not to skip this step. Creating a work order image will allow you to go back in and retrieve the work order even if you are no longer connected to the unit. A date and timestamp will help you find the work order you created at a later time. Step 4. In the next window, enter any notes or information you would like to reference within the work order and click OK. This will now create the work order. Once the work order is created, a communication signal can be seen moving between the laptop symbol and the engine ECM symbol at the lower center of your screen, indicating that the communication has been established. Step 5. Next, click on the Fault Code tab. You may want to set your cursor on the top line of the fault code window and drag it up to see more of the fault codes at one time. Step 6. Open all of the fault code parameters, both active and inactive, by clicking the plus sign of each code. This will allow all of the recorded engine parameters to be seen as they occurred during the fault event. Note: you will be able to see the first and last engine hours for each fault code set. Step 7. Next, you will want to save the fault codes in the open state on your laptop. On the top toolbar of the Insight window, you will find a printer symbol. Click on the symbol and select the correct printer. It is recommended to select Adobe PDF and create a file to save on your desktop. This will allow the field technician to later find and print, email, or attach the fault codes to the Technical Service Request, or TSR, along with all of the other requested troubleshooting data. Be sure to name and place the file where you can easily find it later. It is a good idea to use the Komatsu serial number and SMR as a file name. Step 8. It is now OK to close Insight. You will be asked again if you want to add final notes to the image. Type in anything you want to note and click OK. The program will ask if you really want to close Insight. Click OK and allow the image to save. Do not interrupt this process. Insight will close once the program has completed the image. Step 9. Note: it is not recommended for the technician to clear the fault codes unless instructed to do so by the Komatsu Engine TSC group. The mass airflow sensor is used on all Komatsu Tier IV Interm machines. The sensor is always mounted in the outlet side of the air intake filter housing. Note that the part number for this sensor is the same for all 6D107 through 6D140 size engines. The part number is 6252-81-7900. The MAF sensor is a dual sensor that has a mass airflow output signal along with an ambient air temperature sensor signal. These two signals convert the variations of intake airflow and temperature into a resistance variation and outputs the corresponding signals to the engine's electronic control module. The engine's electronic control module, along with other sensor inputs, uses these to determine the correct proportions of fuel, EGR gases, and Komatsu's variable geometry turbo position to satisfy the broad range of the engine's torque demand. When testing the MAF sensor output, the technician should pre-program the following monitor codes into the monitor. Custom function. Mass airflow 48200. Engine RPM 01002. Injection command 18600. Charge air pressure 36500. Charge air temperature 18500. Ambient air temperature 18400. With key on, engine off, record the sensor values for the listed codes. Next, start the engine and warm the machine to normal operating temperatures as dictated in the machine shop manual. Now, operate the machine and record the monitor values in both E mode and P mode at idle, high idle, hydraulic stall, torque converter or 2-pump relief, and full stall or 2-pump relief, and P max. Note, regeneration must be disabled for the duration of this test. Although the boost pressure sensor is not new to Tier IV Interm engine technology, when using the Komatsu high-definition LCD or other Komatsu style of monitor, it is important to understand the monitor readings achieved. With the key on and the engine not running, the charge air pressure monitoring code 36500 will read ambient air pressure. When performing charge air pressure or boost checks with the engine running, the value achieved with the key on, engine not running, must be subtracted from any result achieved with the engine running. The result is the net amount of charge air pressure. How to monitor charge air or boost pressure. All testing should be performed with all machine systems at normal operating temperature. When monitoring charge air pressure, it is recommended to initially have the key on and engine not running to allow recording of the ambient air pressure. Enter the service mode. Select 02, Monitoring Custom on the service menu screen. Select item using the 5-digit Charge Air monitoring code 36500. Use the Enter key to enter the selection. Record the value displayed on the monitor screen. To determine actual charge air pressure while applying different loads on the engine, start the engine and record the charge air pressure value at idle, high idle, hydraulic stall, torque converter stall, or 2-pump relief in the case of an excavator, and full stall. Again, 2-pump relief with power max in the case of an excavator. From the values achieved during the actual running tests, subtract the value achieved at key on, engine not running. The result is actual charge air or boost pressure. Diagnostic testing. Fuel injector cutout. With the common rail fuel injection system, the injector of each cylinder is separately controlled via electrical signals. The cylinder cutout test can be performed easily by the simple operation of the switches through the monitor. The high-definition LCD monitor allows the technician to cut out or turn off one or more fuel injectors electrically to determine if a particular fuel injector or cylinder is not performing as expected. When a cylinder is selected through the monitor, if the engine speed does not change or the technician sees reduced smoke, that cylinder has one or more defects. Problems that may be considered are lack of compression, defective fuel injector, defective piston or piston ring, defective valve mechanism, defective electrical system. Perform this test while the engine is running. Enter the service mode. Input the 08 Diagnostic Tests menu code by using the monitor's keypad switches. Enter the selection by using Enter switch. Choose Cylinder Cutout. Enter the selection by using Enter switch. Select the cylinder to be cut out using the left or right arrow keys. Press the Enter key. If the background of the cylinder becomes white, that cylinder is cut out. One or more cylinders can be cut out at the same time. Diagnostic testing. Air induction testing. This testing is performed to find any leaks in the air intake system from the KVGT to the intake manifold. In the past, we have seen KDPF plugging issues created by too much fuel going through the engine without the necessary air present to obtain a clean burn. In other words, the air-to-fuel ratio is not at its optimum value. The first step for this testing would be to inspect the hoses to make sure they are in place and there is no damage to them. These hoses would be from the outlet of the air cleaner assembly to the KVGT inlet, from the KVGT outlet to the charge air cooler and to the intake manifold. Today we will only be checking the pressure side, boost, for leaks, since this will change the air-fuel ratio for the engine. We will add up to 30 psi of compressed air to the hoses to check for leaks. The hose from the KVGT outlet side boost should be removed. Using appropriate materials, fabricate a plug that will securely fit inside this hose. Please remember, Komatsu does not have this plug as a service tool. It will have to be made. Each engine platform will have a different size boost hose at the KVGT. During this fabrication, include a 1/8 inch or 1/4 inch pipe threaded hole in this plug to attach an air fitting. Hook up an air regulator to the fitting and allow up to 30 psi to the circuit. Apply soapy water to each hose joint to check leaks. In the past, we have used Windex if soapy water is not available. This will foam up and air bubbles can be seen. You will have to listen and check with soapy water on the charge air cooler also. Leaks in the charge air cooler may be heard before they are seen. If any leaks are found, tighten the hose clamp to its specified procedure according to the engine shop manual. Diagnostic testing. Boost oil pump pressure testing. The service technician should understand how the KVGT and the EGR valve on this series of engines are moved or positioned hydraulically. The oil that creates this movement is engine lube oil that has had its pressure boosted, hence the name boost oil pressure. When fault code CA2387-KVGT servo error is present, it is important for the technician to understand the KVGT operation before troubleshooting the system. The engine ECM, through complicated algorithms, determines the required position of the KVGT hydraulic actuator in order to get a specific turbo speed. The ECM sends a current signal to the KVGT EPC, which opens to allow control oil pressure to flow to the KVGT actuator, which moves the nozzle ring inside the turbo. The KVGT also has a stroke sensor connected to the actuator, which reports the position of the nozzle ring back to the ECM. If the position signal back to the ECM does not match what the ECM requested, the error code CA2387 becomes active. The first part of this procedure is testing the boost oil pressure to confirm it is within the specified value according to the shop manual for the respective machine. All engines in this series have a minimum boost oil pressure specification of 12 kilograms per centimeter squared at idle RPM. For the 6D107 and 6D114 series engines, a run T fitting, PN 799-401-3100 should be installed in the boost oil line that comes out of the EGR valve on its way to the KVGT. In the shop manual, this line is called the KVGT drive hydraulic circuit. For the 6D125 and 6D140 series engines, the boost oil pressure is measured in the top of the EGR valve. A test fitting needs to be fabricated using banjo fitting PN 795-401-1310. A diagram to create this fitting is published in the beginning of Section 30 of the Machine Shop Manual. When this pressure is tested and the boost oil pressure is within specification, but the CA2387 fault code is still active, there are usually two common causes. The boost oil pressure goes through an inline mesh screen filter in the KVGT body under the actuator assembly. If this screen filter has debris present, the boost oil cannot feed the servo valve in the actuator. The KVGT nozzle ring is sticking and not moving easily to the desired position. In this case, the KVGT will need to be replaced. The second part of this procedure is used when the boost oil pressure is less than the specification. First, inspect the inlet screen filter to the EGR valve. This screen filter is located in different places depending on the engine series. For the 6D107 and 6D114 engines, this screen is in the bottom of the EGR valve. The pressure piping must be removed from the boost oil pump to the EGR valve. The fitting at the EGR valve must be removed to locate screen. It is just above the fitting. A 6mm Allen wrench can be used to remove this screen. Check screen for debris blocking the oil flow. If the screen is plugged, clean it and reinstall. Recheck boost oil pressure to confirm it is now within specification. If the debris cannot be removed, the screen filter will need replacing. For the 6D125 and 6D140 engines, this screen is inside the banjo fitting, where the boost oil pressure piping connects to the EGR valve. Finally, if these screen filters are free and clear of debris and the boost oil pressure is still low, the boost oil pump will require replacement. Once the boost oil pressure is within specification, the code will clear when the engine is started. Diagnostic testing. Measuring fuel injector spill rate. This test is also referred to as measuring return rate from injector in some Komatsu publications. The purpose of this test is to determine if too much fuel is leaking out of the return side of an injector or group of injectors. High fuel return rates can cause poor combustion, which may result in low cylinder temperatures, hard starting, and low power. These symptoms may also cause issues in the after-treatment regeneration system, such as frequent, inefficient, or very long regeneration events. The service technician should make sure he has the latest version of the machine engine and shop manuals that specifically relate to the machine model and serial number. Park the machine on level ground and lower the work equipment to the ground. Stop the engine and wait at least 30 seconds to allow residual fuel system pressures to dissipate. Keep a fluid collection pan handy to collect excess fuel. Next, make sure the engine fuel line connections that you are going to work with are free of dirt and other contaminants. Remove the check valve from the cylinder head and disconnect the return fuel line. You will need to isolate the return fuel from the limiter and the injector fuel return. Please reference the shop manual for the correct fittings to perform this task. Install a test fitting in place of the check valve that includes a flexible hose which is long enough to reach into a measuring flask. Start the engine and run at idle RPM. Measure the fuel spill rate over a 60-second period. Please reference the shop manuals for specifications. After measuring the spill rate, return the machine back to its original condition. Testing engine blow-by pressure. One of the tests you will be required to perform when following Flash News FN 12061 is the blow-by test. For details, specifications, and the fittings required for this procedure, please reference the unit engine and shop manuals. Please make sure you have the latest version of the manuals for the specific model and unit serial number you are working on. In this exercise, we will be testing the engine blow-by to see if it is within specifications. If the engine blow-by is above specification, it can cause issues with the aftertreatment regeneration system of the Komatsu Tier IV Interm engines. High blow-by can be caused by bad or worn cylinders, which can lead to excessive engine oil burn, causing intrusion of engine oil into the KDPF. High blow-by can also result in low compression, which can cause heavy black exhaust smoke and high soot loads in the KDPF. High engine blow-by can also be caused by a bad or leaking turbo. A failed turbo can be confirmed by bypassing the turbo crankcase. We will detail this later in this exercise. This test will require the use of a Komatsu blow-by test orifice. Note that Komatsu only recognizes two orifice sizes, the .221 thousandth of an inch and the .302 thousandths of an inch orifice. Most service manuals will list a kit number for this test. We will break this down to help you identify if you have the correct orifice needed for this test. Kit number 799-201-1504 will cover most of the Komatsu engines, including the Tier IV Interm engine, since it has the .302 orifice in it. The 799-201-1511 is a .302 orifice and has an aluminum body with a brass inserted orifice. The 795-790-1900 is a .221 thousandth of an inch orifice and has a plastic body. Note, the .221 orifice is only used on the Komatsu 102 engines. Do not use this orifice unless it is directed by the service manual. A water manometer is recommended by the TSC group as the gauge of choice when performing the blow-by test, since it requires no formal calibration and is not as erratic as a manual gauge. Make note of the scale for the manometer you are using. Inches or a centimeter of water is recommended, and this can be converted later to whatever scale you need as per the shop manual specs. Komatsu Tier IV Interm engines include a closed crankcase ventilation filter assembly called the KCCV. This device must be bypassed to properly conduct a blow-by test. When bypassing the KCCV, it is critical that hoses and ports are correctly plugged to prevent intrusion of debris that could cause additional engine issues. Warm up the engine so that the coolant and hydraulic oil temperatures are within operating range. Disconnect the crankcase pressure sensor connector. Make sure to unlock the connector on this sensor before attempting to disconnect. Disconnect the gas inlet hose on the KCCV coming from the crankcase. Cap the port on the KCCV where the gas inlet hose was removed. Next, remove the gas outlet hose of the KCCV and plug the hose and cap the corresponding port on the KCCV assembly. Install the blow-by test orifice into the free end of the gas inlet hose. Connect the manometer to the blow-by test orifice. Reconnect the crankcase pressure sensor. Run the engine in full stall as described in the shop manual and measure the blow-by. If the blow-by pressure reading is high when compared to standard new spec in the shop manual, section 20, standard engine values, then the turbo will have to be bypassed to make sure it is not the cause of the high blow-by. In order to bypass the turbo, you will need to remove the turbo drain line and allow the oil to drain into a clean drain pan. It is recommended on all engines that you purchase a new turbo drain line to perform the remaining tasks. Please reference the parts book for the turbo drain line part number. First, remove the original turbo drain line and store it for later use. Next, cut the new test drain line about half the distance from the base of the turbo to the inlet of the oil pan. Cut this tube in such a manner that you can get a long hose on the bottom of the top piece that will now lead the turbo lube oil temporarily into the external drain pan. Now install the bottom half of the cut drain line onto the engine block and plug this tube with a cap or a hose with a plug on the end of it. Run the engine at high RPM under proper stall conditions and measure the blow-by pressure. If the blow-by pressure is now normal, the turbo will have to be replaced. Once the new turbo has been installed, return the original turbo drain line and confirm the blow-by is now within spec by performing the blow-by test again. Return all KCCV fittings and hoses to their original condition. This concludes the Komatsu Tier IV Interim Engine Troubleshooting video. This video is the result of collaboration between Komatsu America's Technical Support Center members and the Cartersville Training Department staff. We hope you have found it educational and will use it to enhance the level of experience with your technical employees.